Hi everyone. We're going to continue factoring trinomials in the rest of this section now. We're doing the second half, but now we have trinomials where I have a coefficient in front of my x squared that is bigger, that is larger than 1. Now I have a 2 here, and that complicates this significantly. So we are not going to be able to just see what multiplies to be 12 and adds up to 11, and we're not going to do that anymore. It's very, very similar. There's just a couple of extra steps. So similar, just a little bit more. So step number 1, remember that the coefficient in front of my x squared is a. I'm going to call this always a. This is my b, and this is always my c. So step 1, and you might want to write this in your notes. Step 1 is multiply a times c. Take this number times this number. So 2 times 12, in this case, that's 24. Okay? That's step 1. Step 2, try to find factors of 24 that add up to b. So see, it's just that one extra step. Instead of factors of 12 that add up to 11, it's factors of 12 times 2 that add up to 11. Do you see that? So that's step 2. Factors of AC whose sum is B. All right, so two numbers that multiply to be positive 24 add up to 11, and I think that would be 8 and 3, right? So we are going to do 8 and 3. So we've done that part. Now we are going to rewrite this equation, and we're going to split b into 2 terms, and it's going to be these 2 terms. All right, so let me show you how that works. We're going to rewrite this 2x squared, and this, instead of being 11x, it's going to be 8x plus 3x. I'm going to split it into 2 terms. Plus 8x plus 3x, and then 12 doesn't change. Okay, so now I have split b into 2, and now what I'm going to do is I'm going to divide this now 4 terms in half. I'm going to put them in 2 groups. So here's step 4. Group the terms and pull out the greatest common factor. And find your GCFs. How's that? Your greatest common factors. Okay, so this is, I'm running out of room here. Here's how you will group like that. And now just take these first 2 terms. What's the greatest common factor between 2x squared and 8x? The number would be 2, and they both have an x, so pull out 2x. When you divide this by 2x, you're left with an x, and when you divide this by 2x, you're left with 4. So 2x times x plus 4 equals that, right? Now we look at this. What's the greatest common factor between 3x and 12? And it's a positive 3, so we'll pull out the positive 3. Here we're left with the x, and here it's plus 4. Notice these 2 are the same. X plus 4 is one of my factors. In this situation, x plus 4 are being multiplied by 2x and by 3. That's my other factor. So my first factor is 2x plus 3. And the other is x plus 4, and I've factored it. I'm done. All right, and now how do I check? If I FOIL this, I should get back to my original equation. In fact, when I first FOIL it, it'll go to this, which would, then you would add these 2 together. Do you see how we're kind of going backwards? That's how this works. So after we grouped the terms to find the greatest common factor, then the last step is then to divide those into your 2 binomial factors. All right, let's try some more. Okay, in this next one, we have 4x squared minus 4x minus 3. So our first step is to multiply 4 times negative 3. We get negative 12. All right, negative 12. So factors that will multiply to be negative 12 and add up to be negative 4. And I think that's negative 6 and positive 2, right? Do you see how that works? So negative 6 and positive 2 multiply to be negative 12, add up to be negative 4. So I'm going to split this b into two terms and rewrite this, 4x squared. And this is going to become minus 6x plus 2x and then minus 3. Do you see how I've split this into two? That's how I determined what they would be. Now I group and find the greatest common factor. The greatest common factor between these two is 2x. So I pull out the 2x and I'm left with 2x minus 3. And here there's nothing common. When there's nothing common, just pull out the positive 1. So this is just 1. My greatest common factor is 1. Pull it out. And I'm left with 2x minus 3. Now, if I did it right, these two terms should be the same, and they are. This is one of my factors, not two of them, just one. This one is my other factor. So 2x plus 1, right here, that's my first one, 2x plus 1, and 2x minus 3, and I have just factored it. How do I check? You FOIL that. If when you FOIL it, you get this, we did it right. I really want you guys to practice this. It really helps, and it just takes doing it a few times to get the hang of it. So go ahead and write this down, 4x squared plus 7x plus 3. Pause the video and try to work it out on your own, and then restart the video and I will walk through it. Okay, so you should have multiplied 4 times 3 and gotten 12, and then looked for factors of 12 that add up to 7, and that would be 4 and 3. And then rewrite this as 4x plus 3x. Split that up into your two terms. By the way, it doesn't matter which order it is. Doesn't matter at all. You'll get the same answer either way, so don't worry about that. Okay, now I'm going to factor by grouping. I can pull out a 4x here, and that leaves me with x plus 1. And I can pull out a 3 here, and that leaves me with x plus 1. So that means I have 4x plus 3 times x plus 1. How did you do? I hope you did well. Let's try another one. This one has some tricky sign issues to go with it. So write 2x squared minus 7x plus 6. Copy that down, pause the video, work it through, and then restart it, and I'll walk through it to see how you did. Okay, you should have started with 2 times 6 is 12. Two numbers that multiply to be positive 12 and add up to negative 7. That would be negative 4 and negative 3, right? So we rewrite this, splitting it up. 2x squared minus 4x minus 3x plus 6. Put it in two groups. Find the greatest factor, 2x, x minus 2. And I'm going to pull out the negative 3, x minus 2. I don't want this to be negative, so I pulled out the negative, which changed both of these signs, and I did it right because my x minus 2's match. So now this is 2x minus 3 times x minus 2, and I can FOIL to check my answer. This one had some tricky sign issues. This is called a perfect square trinomial because when you factor it, the two factors are the same. So they're the same thing squared or times itself. For instance, what two numbers multiply to be 25 and add up to be 10, and you realize it's 5 and 5. So this is x plus 5 times x plus 5. So this is called, you can write it like that, a perfect square trinomial. There's a pattern to these. The pattern, when you have a perfect square trinomial, is you have a squared and then plus 2 times a times b, right? 2 times 1 times 2ab plus b squared, right? Yeah, b squared. Because my a is x and my b is 5. So this is x squared. This is 2 times x times 5, or 10x, and this is b squared, or 25. So you get that kind of pattern. And if it's a negative, then this becomes a negative. All right, this is in your book. These are helpful. All right, sometimes when it's just a plain simple x, they're a little bit easier to see. Sometimes they can be more complicated. For instance, when you see a problem like this, it might be a perfect square trinomial, which would be cool. One thing though that I would recommend, if you look, there's a greatest common factor that you can pull out of this. Do you guys see it? You can pull out a 4, factor out a 4. That's what I would do. However, leaving that aside, this is the example in your text, so this is the one that I'm using. If you see that both the a and the c term are both perfect squares, it might be worthwhile to see, is this a perfect square trinomial? If it is, this would be the square root of, the first term would be the square root of this, and the second term would be the square root of this, with that sign. So if it is, it would be 2x, and the square root of this is 6, and because that's a negative, it would be 2x minus 6 times 2x minus 6. Do you guys see how that works? And it works. How can you check? FOIL. So if I FOIL this, by the way, this does not mean 2x squared minus 6 squared. It means 2x minus 6 times 2x minus 6. So when I FOIL, I get 4x squared minus 12x minus 12x plus 36, and sure enough, it's a perfect square trinomial. Notice when I said you could factor out a 4, notice this can be divided by 2, but still, it's a perfect square. Here's another one. In the textbook, it's kind of nice because when we're working for perfect square trinomials and you're working in that section, you know to look for it, so you know what to do. If you don't, and you're just going on along and you just go 64 times 1 is 64, factors of 64, and you just walk through the steps, they'll still work. They'll still work. But if you can see the pattern, it's helpful. For instance, this is a perfect square, and so is this. The square root of this is 8x. The square root of this is 1, and this tells me it should be a negative. And there you go. And you can just FOIL it and see if it works. And in this case, it does. This pattern is really, really important, and I want you to be able to recognize this. If you have one perfect square minus another perfect square, we call this the difference of two squareds. I want you to see them, recognize them. They're super easy to factor. What you end up doing is, and the a, whatever a is, whatever b is, this factors to be a plus b times a minus b, always. And here's why it works. So if I FOIL this, right, this is a squared, this is minus ab, this is plus ab, this is minus b squared. Notice how these two middle terms drop out and you're left with a squared minus b squared. So if you recognize this pattern, memorize it, you will see this a lot. Difference of two squareds, just a difference of two squareds, and you'd use this pattern. So let's look at what this looks like with numbers. Here's a real simple one, x squared minus 25. So the square root of these are both perfect squares. Square root of this is x, square root of this is 5. So this just falls under that pattern, x plus 5 times x minus 5 in any order. Could be x minus 5 times x plus 5, doesn't matter, but this is the pattern for a difference of two squareds. They can be more complicated. Here's an example of when they're more complicated, but still notice this first term is a perfect square. The square root of this is 5x. This is also a perfect square. The square root of this is 7, and this is a minus. This does not work if it's a plus, only if it's a difference, not a sum. So this becomes 5x plus 7 times 5x minus 7, and you're done. So I really want you to get used to seeing the difference of two squareds and being able to factor them quickly and easily. All right, your lesson check for today. Here's your lesson check problem for today. Tell me what the factors the factors are of this difference of two squareds, and then I'll know that you watched the whole video and all the way to the end. And that's it for this section. Factoring, still my favorite thing to do, and you will be using this a lot, so you want to feel really comfortable with it. All right, so bye for now.